was in robotics and automation, and after that I joined you. So we'll be having a lecture on introduction to robotics today, and I'll share some of my experience, what I did in robotics during my master's. So what is the thing that comes to your mind? The first thing that comes to your mind when you hear about robots? What is that thing? Sorry? It could be androids in Star Wars, Terminator, Star Trek, everything, right? They all capture your imagination, but still they exist in science fiction. You might not have seen them in real, right? So we'll see how real robotics and how the transition from real robotics to science fiction and how robots evolved over time. We'll see all those in the lecture. So today we'll be covering definition of robots or robotics or robotic systems. We'll see some different types of robots, their uses, history, how they evolved over time from fixed to mobile robots, and even cloud robotics. Then some key components of robots and their control system, how they are controlled, and different parts of robots, applications, and the future. So, can you give me some examples where robotics is being used or robotic systems are being used? Which you have seen or have seen working them on some applications? Yes, Mars rover, right? And then we have different commercial uses of robots. Industrial robots, we'll see that the first robot that was developed is an industrial robot and how they were used on an assembly line. Healthcare, you might have heard that they are now being used, nanorobots are being used in surgery and stuff, or even industrial robots are sometimes being used in surgery. Entertainment, obviously, Star Wars, all these Star Trek, Terminator, Matrix, iRobots, you might have seen evil robots as well, right? And then agriculture, etc. So the critical view is that all these are the good application and for good cause of the world. But then International Committee for Robot Arms Control have a rule that it should be used for good use, I mean social robots kind of. So they have put some restrictions on the use of military robots as well. So that's just a law that all the robots, it's not that they are used for evil, they should be for good cause. So that's the law which states that it should be for good for people and the world. Robotics can also be seen as intelligence research. So what's AI?
Intelligence.
What's that?
Artificial intelligence.
That is in the machine.
Artificial intelligence.
We'll see how during the lecture we'll see the different components of robots and the interdisciplinary nature of robotics. In that we'll see that AI is one of the important elements and machine learning, etc. all those stuff. So AI is nothing but introducing intelligence to machines. That's called artificial intelligence. So we'll see how AI in real world is different from classical AI. So AI in real world actually means interaction, manipulation, and perception and navigation in the real world, right? So we'll see that how classic AI, which is studying the intelligence in humans and insects, because that's the actual intelligence, right? You might have seen ants which move from their home to the place where there's food, and then they actually leave trails. So that behavior is being written and created as mathematical model and being input as programs in the robot, and that's the classic AI. Artificial AI, which is the real world, that's what I was talking about. But the not so real AI is the one where your entire world is programmed and then robot is programmed accordingly so that it acts in that world, right? So that everything is programmed. That's not the real world AI. So those are the two different things. So the behavior, interaction, intelligence of insects and humans, or the living beings, how they behave, that has been studied and that has been converted to mathematical models and algorithms, and those algorithms are being used in robots so that they behave with intelligence. Otherwise, they are just machines, right? So this was what I was talking about. Why AI needs to go to real world? The main thing in this world is motion, right? You have to move, you have to go somewhere. There is some destination from your starting point. So that was the main motivation behind AI going to real world. It was a driving force to develop intelligence because it has got all the main components of a human cognition, neuroscience, plus the control and decision-making capability of humans or other living beings, and it needs anticipation as in deciding that, oh, there is an obstacle, it has to avoid it, otherwise it will just go and hit. So that intelligence is actually in the living being, not in machines or robots earlier. And then planning how it wants to move to that location or taking the shortest path so that it minimizes power and time and reaches that place as soon as possible. And it needs perception, as in viewing how the world will look like or how over time that world will change, everything. And it needs spatial representation, which is, you have seen maps, right? Google Maps. It tells you about which thing is at which place, which location is in which place, which building is at which place in any location, all that stuff. That's the spatial representation. And the next motivation is manipulation. The manipulation is nothing but interacting without actually touching the object. So that's what industrial robots earlier were meant to be. They were fixed and they were programmed in such a way that everything can be manipulated without a human, they don't have to touch, just with the industrial robots they can do. The manipulation requires knowledge of the structure. So you might have seen, have you seen anyone car assembly line? Have you seen the manufacturing of cars or any, this kind of stuff? So you might have seen that there are robots which have arms like this, based on the claws or the kind of part they are going to fit. So you need to have idea of the structure which is being built. So according to that, the manufacturing requires knowledge of the structure of any material which needs to be built. And structure means that nothing but geometry, physics, and objects, how they can be molded, how they are currently located at which part of the device or the object in the real world. But classic AI doesn't, because as I told, classic AI, where you program entire world, so you can program according to what you want, and robots will then behave. But this is the real world here. And some more into robotics and intelligence research, we'll see some of the fields here. So machine learning and artificial intelligence are some of the disciplines which are part of robotics, and they are computational disciplines. You see during your course, if you take computer science or electronics or say computer science and electronics, because this is an interdisciplinary field. Even if you go for mechanical engineering, you will be using some kind of models to train them on some particular data set. So that's what is machine learning. You have a model, you train them based on some sample data set, and then you can apply that one to the actual data set. So that's what is machine learning. You are making machine learn. How do we learn? We see something, we know that, oh, this is how it works. And over time we see certain things, we see the pattern, and then when you go to the actual thing, we see that, oh, that was working like this. This also works. Right? That's what is machine learning. And they are the computational disciplines because you make use of different algorithms, computational algorithms, and mathematical models. And they also involve statistical modeling. Have you done statistics and mathematics, right? In your undergraduate. Binomial distribution and all those stuff. Just creating graphs, observing patterns, how the trend is going. So that's called statistical modeling, how you predict the outcome and stuff. And analysis of data sets, as I told you, have a sample data set that's being analyzed, and then you see how the robot or any machine will behave later on. Autonomous learning, and that's again based on programming of the robot and all these models that will be used in creating intelligence of the robot and reasoning in real world. This is currently in progress because you'll see how robots evolved and how intelligence is being injected into robots. And there is descriptive science, which consists of neuroscience and psychology. So people who have, that's why it's called interdisciplinary, because people from neuroscience, psychology, they know how humans behave. So they work with mathematicians and computational scientists to mathematically model that kind of thinking. That's cognitive science, right? So that's why robots are becoming intelligent these days, when people from all these fields are trying to model everything and then put into these machines. But these two are just not sufficient as, individual fields. They have to be merged together, and that's what is robotics. It's a synthetic discipline. It consists of computational and descriptive sciences to understand intelligent behavior in natural world, like how humans behave, how humans react to any situation, how humans move in real world, and all of that. It tells us the actual problems, because that's where the problems lie in the real world when trying to organize behavior in real world. So we have already covered what are robots. It's been created by humans, right? All the machines that are created by humans. Even your fan is a robot, kind of robot. It has a control panel, but it's just you are controlling it. You have a regulator, you can control it. You have speed and. So it's a reprogrammable, which means we can program it as and when we want to change its behavior or actual action, what it's supposed to do. Multifunctional. Earlier, initially, the industrial robots were for specific applications, like on the car assembly, it's just used to fit the door of the car. But over time, all the robots have been programmed and made multifunctional, as in even a robot which can fit the door can fit maybe wheels. They can have multiple arms or kind of shapes in the manipulator, so they can do that. Designed to move materials and tools, as I said, and any specialized devices through different programmed motion and for performing different tasks. And that's what a robot is. You can recognize that. This is a manipulator, and these kind of robots were the first ones which were created for industrial purposes. CNC machines, tooling, drilling. The machine that does drilling is also a robot. They are not specifically called robots, but they call it manipulators, because based on the geometry and the structure of the object that they are going to drill or shape, so that's why it's called manipulator. What's this one? Big dog. You might have seen it. It works on trains as well. Boston Dynamics one. So that's how they evolved. They were just fixed. You might have seen the previous one. It's fixed. You cannot move it anywhere. They are so big things. And now slowly moved on to mobile robots, where people can't go. They send these robots to, like the Mars rover, which was sent to Mars to identify water traces and all this stuff. And wheeled robots we have got next after industrial, and then autonomous underwater vehicles, submarines, and also where to reach the places where humans can't go. If it was whole water bodies occupied with some harmful chemicals, they send these kind of robots to identify coral reefs or any other harmful chemical, to take the risk of it and then analyze it later on. Unmanned aerial vehicles. Don't you have heard of drones, right? Yes. So that's also one kind of robot. So they evolved from fixed, manipulated, to mobile robots. Now these robots are also moved on to wheeled robots, and then they carry on stuff from one place to another. How do you think these Amazon and big warehouse companies they work? Humans can't move such huge material inside the warehouse. So they use these kind of robots to move stuff and stack them up in their warehouse. So these are called warehouse robotics. So fixed are the manipulators one, used in manufacturing and they can't move their base, they are restricted to one location. And the mobile ones have either legs or wheels, and they move entire industry or warehouse and then help people or any company to achieve their task. Use it? So usually for normal jobs humans can do it, but the ones which are dangerous, so they send these robots to those places and then identify the environment and any other stuff they want to analyze. Like the decontaminating robot, because humans can't go to nuclear power plants where there is radioactive fumes and gases, or for cleaning the pump housing, so they use decontaminating robot for that. Another type of use is a welding robot. Sometimes it's dangerous to, or it's dangerous when we are using some harmful welding material. So we have welding robots for that, and we get bored very easily, isn't it? Doing same kind of tasks, but robots don't. So we use robots for stressful, boring, and very expensive tasks. Medium tasks which people don't like and dirty places, they send robots and submit robots, and then they are used for cleaning. So everywhere the robot is being used. Have you seen Roomba? People are using vacuum cleaners, they are also robots. There's the automatic vacuum cleaner which locks itself when the charge is gone. So let's see some history of the robot. The first one is Unimate, which was used on General Motors assembly line. And 1978, before 1978 it started, and then in 1978 Puma robot, which is programmable universal machine for assembly. That was originally developed by General Motors. And this was also used on assembly line. And then over time, during 1980s, it enters a phase of rapid growth where we started developing mobile robots and then different small applications in social and mobile robots, and which gave rise to many startup companies and research. And in 2003 we had NASA's Mars exploration rover that was sent to space and then to Mars to find water traces on Mars. So that's how robots evolved over time. So what are the things that consist of robots? Without seeing this slide, what are the things? What do you think? What makes it intelligent? What are the things in the robot? Software and hardware, and they come under different things like sensors, control systems, and sensors has got variety of sensors: motion sensors, vision sensors. Camera is nothing but a sensor. And then the main control system which controls all these things. For wheels they use actuators. That's for moving. So some of you who may take mechanical engineering or have some mechanical engineering background, they might be aware of dynamic systems and their voltage analysis. They are also used as a subfield of robotics. Feedback control. That's what controls every part of the robot. So once you send some input, robot does something, and then it feeds back to the that is done, and then it will say that this is the output, and that can be used and be asked by the robot or sent to robot that you have to perform now this thing because you have done that thing. So that's what is
我们那个咱们那个演讲得准备准备。
Sensors and then signal systems you might have seen in your electronics.
我找到了更细的。
And actuators which are used to drive any part of the robot. You can put motor even for if you use motors even for the manufacturers you have seen, they put motor at the arm and then they move.
I've seen them.
Oh yeah. And power electronics, so they use from low to high voltage electronics, all range of electrical and electronics. What's happening to this system? Yeah. Hardware and computer interfacing to see the visuals of how the robot is performing, or if say you want to control from here and robot is operating somewhere else. And if you want to see any of the analytics and okay, so computer interfacing and then programming, because that's what is automating all the tasks, right? Otherwise you can just put motors and anything can work. But in order to control it, you have to tune the control system, take some parameters which make it faster, and then with computer programs, because industrial robots they weren't consisting of computer programs mostly, but they were just doing some specific tasks, say fitting something. So they don't need any computer program. So now these robots have computer programs which also makes it possible to change the functionality of the robot, change the program, because you don't have to change hardware every time. So that reduces hardware cost. So what all disciplines that consist robotics? Electrical engineering, all this stuff that we have seen. So we have artificial life, psychology, neuroscience. It's so nice. Physics, mathematics, because we are using lots of mathematical models. Electrical engineering, control theory, which is the most important stuff, and even the feedback and all the stuff is in control theory. Computer science and engineering, of course, and mechanical engineering, all the parts are built based on mechanical engineering. And then logic, how the robot should behave, or what kind of task it's supposed to do. So, in short, how each part of the robot is linked together. You can see that so we have the main thing is the controller, which is used. Let me draw this stuff. That would be good. You have answers? Yes. Okay. So we have controller, which is the main one, and of course controller also needs power supply, right? So this is the power. Then we have a controller, which is controlling everything. You have sensors, and all other individual devices as well require power, right? For them to operate. So they require power, and even the actuators need that. And you have the base and manipulator here, mechanical stuff. And then user interface, which is the GUI, right? GUI, right? That's the user interface. So that's for observing and making it easy for users to access and operate the robot. And controller is also very interactive. So this is the one which has got all the feedback and signals that are being sent from sensors, actuators, even the So the controller now, based on whatever data it gets from the real world, from actuators, sensors, because sensors can send the visual, whatever they see about the environment or the map, to the controller, and then controller will know now how the real world looks like and ask the manipulator to perform certain tasks. So So that's how this whole system works. And more or less, every robot has this kind of structure. Yeah. So, considering different parts of the robot and how they are linked with different kind of mechanisms, so you can see that kinematics and dynamics comes under mechanical engineering, and that's about controlling the movement of the joint, if at all it's an industrial robot or any other mobile robot which is performing the task of construction and shaping stuff. For desired movement, it does this. So the desired movement is based on the map that the controller will be getting from the real world sensors and actuators, and then ask the manipulator and orchestrate its joint movement, and it controls them. Planning and optimization. So from sensors it got now grid-like view of the real world, where are the obstacles and whole structure and map of it. So now with the controller and tuning of the controller, it can help robot plan how it wants to move around its map, right? It now knows where everything is. So that comes from the planning. And optimizing trajectory is nothing but planning the path. So it's not necessary that you want to go by this particular path itself, right? So you use computer algorithms, you might have seen in data structure, that how you can go through a short path, right? So it takes the graphical view of the map that it gets from the sensors, and then it plans accordingly and goes through optimized trajectory, which could be a shortest path without obstacles. So that's how it plans. Control theory, which is tuning of the controller and designing of optimal controller based on the parameters. And mobile robots, which the main thing is localizing and mapping itself. So localizing and mapping consists of all these things because that is the end task that anyone wants to achieve. So localize itself at a particular location, and then see where it's in the map, and then go to the destination. So mechanical elements mostly consist of gears and gear trains, and then sensors like accelerometers, flexible sensors, vision sensors, all comes under sensors. Proximity sensors, which are for detecting anything is near to the robot, so as to avoid it or pick it up or something like that. Controller provides the other side. This is the one which is collecting data from every other part of the robot, and then it's used to provide intelligence to the robot, which is the main body of the robot, and then perform the task accordingly. Storage hardware. So of course, because it's getting data from here, it needs to be stored somewhere, which is like we have RAM and different memories in computers, so we have same kind of stuff in robots. Computation hardware, which is used to calculate where I need to go, which part I have to avoid, so it has to calculate distance and some parameters to avoid stuff. And then the interface hardware, which is, there are different wires, cables, all those are the interface hardware. So robots in industry, we have seen earlier, they are used in agriculture, automobile industry, for car manufacturing, entertainment, healthcare for surgery and stuff, manufacturing, military robots, transportation and warehouse, all these big robots are used and utility. So before we go on to this, my master's thesis was in robotics and automation, and I have done mapping of the lab I was working in, using the cloud robotics, because the problem I faced was the memory in the robot was not sufficient because of the resources that were available to me. So we thought of an idea to put the sensor data, whatever it was mapping in the real world, into cloud. So you have heard of cloud robotics.
Yeah.
That's a foreign term now, but it's actually where you store your data and then you take it when it's required. So now your memory is not occupied with all the data that you are getting from sensors. If you use laser sensors, which just gives you one array of data of the environment that it sees, I used Kinect, Microsoft Kinect. So it gives you depth data, which is like huge. So for processing that data, the memory was being occupied every time, and then it slowed the robot, because the same memory is being used for its movement as well, right? The data from memory. So we put this in a cloud, which was provided by Amazon Web Services. We used that, and then I used one robot cloud engine, which is like a storage space for all the robots, where they can store the map of the environment which they are in. So it stores based on latitude and longitude of this. Let's say I want to create a map of this lecture room. So I can put latitude and longitude of this, and then it stores the grid map that it generates from the sensor into that. So it's like an ID with which it will retrieve. That it's in the environment, it will retrieve the data, the controller, and then it asks the manipulator, okay, now traverse the whole room, and over time, the atmosphere may change, right? Say tomorrow I will move this table out. Now robot is not aware of this fact. We will be aware of this fact because we can see and we have that intelligence that this is an obstacle, it wasn't there earlier, but robot doesn't. They didn't remember that it was there earlier, right? So whatever map that was given to them, it takes that. So now, it's not there, but still it will try to avoid, because it had earlier map. So there was a facility in the cloud engine, with which, based on the time from yesterday and today, it took that map, and it took today's map, and then it now traverses as if there is no. So that's called temporal change of location. With time, your location changes. So that was part of it, and it included all the aspects of it, but just that I didn't design any robot, but we programmed it and then optimized the controller based on the proportional integrator and differential tuning, and then created obstacle avoidance algorithm. You'll come to know that you'll be doing algorithms and stuff, and then did that stuff. So that was this, and let's move on to other areas where it can be used: space, hazardous environments, even in the places of the world where humans can't go, medical robotics, military, and which we already covered. Future. So artificial intelligence, which is now being used to give intelligence to machines based on the real world, so that it senses that what actually changed, what was there earlier, and then make decisions accordingly. Humanoids, we have already seen a CMO, right? And then nano-robots, which react to human emotions as well. So slowly we are getting there. And even in ECS Southampton, you might have seen rhino somewhere, right? Have you seen the rhino? No. So it's in Zeppelin, if you get a chance, go there. It's made of Raspberry Pi, Arduino Raspberry Pi device. They are mini computers. So it's made of that, and it works on Wi-Fi, and it actually reacts. It was as an entertainment stuff for children. It was put in the school and here in Marlet and stuff. So the same kind of behavior is being put into humanoid robots, and that's how we'll see how future will be with robots, and it's for a good use. Any questions? And these are some online examples. We have got robotic systems and software course in the university, and different modules also cover basics of robotics, plus you can go into specialization based on which kind of robotics you want to go. There are specializations like localization and mapping, so you'll be working on entirely mapping and obstacle avoidance algorithms, different kind of navigation algorithms, localization. Or there is specialization in just control theory, where you will be working on tuning and optimization of the controller. Or you can go in artificial intelligence as an application to robotics, so also specialization is there. And these online courses you are already aware of. Coursera, they have driverless, self-driverless cars, course, and all this stuff. You can learn from there, or you can email any of us or any university
AI is programmed to do something which source come from the past data, then is it possible that AI pass the data?
Past.
Yeah, past data. Then AI create something such as a writing model or create new thesis. Is it possible? Create new things.
Oh, it can't, it may not be able to create new things, but it may tell you that this can be possible, like predicting
Yeah, predict.
from the past data. Yeah, it's possible. So that's what machine learning does. You give past data, you train a mathematical model. It could be logistic regression or linear model based on the task that you want. You create a model.
I heard that the Amazon are using the shopping data and they apply to the customer.
Yes,
But
that's because they want to sell certain things, right?
So
And
not
if-
kinds of that, just create the novels or the writing novels or the new thesis. Is,
new disease prediction.
yes, or the
It could be based on symptoms.
the possible.
Yes, they are doing that. I have seen one where this, this deep blue thing, where you can know that a person is going to die or having a heart attack. So they predict based on the symptoms that you have got, and then they use these models to train from the past data set, and then they can predict that, oh, this person may get this kind of stuff or this kind of heart disease.
Okay, thank you.
But then they are not being used so often because healthcare data is very confidential and they cannot take risks. Machine learning, after all, these are all the models trained by humans, right? You're not 100% sure. Some symptoms just come. So they are being used. But, yeah. Any other questions? What is data mining? Yeah. So you use those machine learning models as a program in robots and they are used. So if robot is, they want robot to perform certain things, or they can't go because humans can't go to certain places, and they want to save, control some pest or some epidemic, so they send those robots, and from the data that they mine from the previous data, and then they can predict the pattern, and then robot will do that stuff. Yes. All the fields are being used in robotics, so that's why it's called interdisciplinary.
Good question.
Yeah.
What advice would you give to these students if they're interested in robotics? What would your tip be?
Yeah, I would say don't go for general robotics. Just think about what aspect of robotics you like based on the topics that we discussed. It could be that you want to go in motion and planning, so that's entirely different research. And if you want to go artificial intelligence, so that's entirely different. Or you want to go in cognitive science side of it, so that's different. So I would say that based on the specialized area that they are interested in, you can take that particular subject. But everywhere there is algorithms, so if you want to do localization algorithms or just the algorithm stuff, you can go for computer science and algorithms. Or there is a department here, vision control, and there is one more department in my field that's called agents, interactions and complexity. So they work with different agents, and they have been working on disaster management. So you can choose that field.
One other question to answer. So if you've got students who have chosen to do engineering, but this has got them interested in another area, is there some way that they can get involved in this kind of work without signing up for the course?
Yes, there are different research projects which take as interns, students as interns. So if you want to, if you are doing in say mechanical engineering, but you have good knowledge of computers and you can program and you can develop algorithms, you can apply as an intern to different research projects in these departments which are actually doing core research, and they do take students in summer, and because you will be having 1 year course, right? So you can take that as master's students and continue that.
Any other questions? No? Thanks very much.